Myself, Dr. K. Viswanath Allamraju, Department of Mechanical Engineering, Institute of Aeronautical Engineering, Dundigal, Hyderabad. In this session, we are going to study what is Lamis Theorem, and we are going to solve some of the problems based on the Lamis Theorem. Here, Lamis Theorem, what is Lamis Theorem? Lamis Theorem states that if three forces are acting at a point or in equilibrium, each force will be proportional to the sine. Each force, suppose if we consider the P force, is proportional to the sine of angle between the other two forces. So if you want to find it, if three forces are acting at a point in equilibrium, that means these two forces are acting some angles which are in equilibrium. Each force P will be proportional to the sine of the angle between the other two forces. So P is the force. What is the sine of the angle between the other two forces? P by, that is the sine beta. So P by sine beta equal to constant. Then what about Q? Q by sine gamma equal to constant. Then R by sine alpha equal to constant. Thus P by sine beta equal to Q by sine gamma equal to R by sine alpha. So here the Lamis theorem states that the P is proportional to the sine of the angle between other two forces. The sine of the angle between other two forces are Q and R. The angle between other two forces is beta, that is proportional to sine beta. Then Q is proportional to the sine of each force. Now I consider the Q force is proportional to the sine of the angle between other two, Q by sine gamma. The next, what about R force? R is the force is proportional to the sine of the angle between other two forces, Q and P, that is sine alpha. So P by sine beta equal to constant, Q by sine gamma equal to constant, and R by sine alpha equal to constant. Thus, these are all constants equate, then P by sine beta equal to Q by sine gamma equal to R by sine alpha. This is known as the Lamis theorem. Once again, why should we find out this Lamis theorem? Lamis theorem is useful to find out these forces, such as if we know the unknown forces, if we know the P and alpha, beta, gamma are known, then we can find out the other two forces, that is Q and R. Or if we know the force R force is known, Q and P can be calculated, this alpha, beta, gamma are known, then this Q and P calculated. The Q force and P force can be calculated by using this Lamis theorem. Similarly, if we know the Q force is known, R is unknown and P is unknown, but alpha, beta, gamma are known values, then P force, R force and P force can be calculated by using this Lamis theorem. So Lamis theorem is useful when three forces are acting at a point, and in order to find out the unknown forces, and if we know the known values of angles between them, or one force is known, then we can calculate other two forces by using this Lamis theorem. By using this Lamis theorem, we can calculate. That's what this point says. So here, what type of force we use here? We use here coplanar concurrent forces system. How many forces are acting here? There are three forces are acting. The three forces are P, Q and R are the forces which are acting at a particle O. The angle made with P and Q is alpha, Q and R is beta, and R and P is gamma. So alpha, beta, gamma are the three angles between the forces PQ, QR, and RP. Okay. Now, how to analyze this proof? So proof of the Lamis theorem. Here we know alpha, beta, gamma is the O, and it is P, and it is Q, and here it is R. PQ is alpha, and Q and R is beta, and QR and P is gamma. Now I consider here the three forces acting on a point are in equilibrium. Hence they can be represented by these three. There are three forces are there, P, Q and R. Now P, Q, R considered as a triangle. The three sides of a triangle taken in the same order. This is the P, and next P is making with the line. P is making with the line how much it is parallel, that is gamma. Next P is making the line gamma, then it is extended, P with extension, then that is the Q is the force. And R you draw. This is a triangle. So here it is gamma, the angle between Q and R. This is the R extension. If it is the gamma, the angle it is 180 degree. So 180 minus gamma. This is the angle. Now Q is making the P is horizontal. Q is making with the angle. What is the angle of inclination? Alpha. What about inside angle? That is 180 minus alpha, because the total is 180 degree. Now this total is again 180 degree, and here this total line is 180 degree. Now this Q, with the Q, R is making, what is the angle? With the Q, R is making, that is a beta. This is R, this is the Q line, this is a beta. What is the angle? There is a beta, but what about inside angle? The inside angle, this is called outward angle. Outside angle is beta. What about inside angle? That is 180 minus beta. Now here, after drawing this, according to applying the sine rule, what is the sine rule? The P is proportional to, what is that angle? P by opposite side angle. P by sine 180 minus beta. Next, equal to constant. P by sine 180 minus beta equal to constant. Next, Q by sine opposite side. What are the opposite two forces? Angle is proportional to the sine of the angle of other two forces, that is 180 minus gamma. Sine 180 minus gamma equal to constant. Next, what about third one? R by sine 180 minus beta. So R by sine 180 minus alpha equal to constant. Alright. P by sine 180 minus beta, Q by sine 180 minus gamma, and R by sine 180 minus alpha are constants. Then P by sine 180 minus beta equal to sine beta, Q by sine 180 minus gamma equal to sine gamma, and R by sine 180 minus alpha equal to sine alpha. Thus, P by sine alpha equal to Q by sine beta, P by sine beta equal to Q by sine gamma equal to R by sine alpha. This is the derived expression of the Lamis theorem. The derived expression of Lamis theorem is P by sine beta equal to Q by sine gamma equal to R by sine alpha. In other words, you can remember is that P by the sine of the angle of between other two forces equal to Q by sine of the angle of between other two forces, and R by sine of the angle between other two forces. That's what we have to remember, because the gamma location, beta location, alpha location, you may not be knowing it. We can know the angle between P and Q is the alpha, Q and R, P, Q, R that is the beta, and R and Q, R and P is gamma. Alright, this is the derivation of the Lamis theorem. Now, how to use this Lamis theorem? That is the application of level of the Bloom's taxonomy. Lamis theorem, let us take a problem and apply this Lamis theorem, then we can understand better the formula, the derived expression of Lamis theorem. Let us begin. Yeah, wait here. What is mentioned here? The problem is this is the figure. The figure consists of chain number 1, that is CA, and chain number 2, CB. The angle between chain 1 and chain 2 is 90 degree. So how to find out these angles? If we know these two angles, between the angle between ACE and the angle between BCE, then we can apply the Lamis theorem directly. Okay. Now here, a weight of 1000 newtons is supported by two chains, that is shown in figure. Determine the tension in each chain. This is the chain 1 and chain 2. The tension 1 and the T2 with the tension 2. So the weight C is 1000 newtons. Angle CAB. What is the angle C? CAB is 30 degree. Angle CBA equal to 60 degree. Yeah, 60 degree and 30 degree. Angle ACB equal to 90 degree. This is what which is shown in figure. So what is the Lamis theorem? Suppose P here, Q and R. Then P by sine beta, Q by sine gamma, R by sine alpha. The Lamis theorem for derived expression is P by sine beta equal to Q by sine gamma equal to R by sine alpha. Okay. Now, how to solve this problem? Now, the free body diagram for this is, we need the angles. How to get this diagram? We'll find out. We want this is T1 and it is T2. It is T2 and it is T1. Here it is 60 degree. The angle between ACD is 60 degree. How to get this? If it is 30, okay, it is 60 degree. Okay, now how we got this 60 degree? It is given in the figure. Is a right angle triangle. 60 means this is 30 degree. Then again the angle between horizontal line is both are 90 degrees. This is 90 degree. So angle between ACE is 120 degrees. Now here coming to this portion, coming to right side portion, that is ECB. Now here it is 90 degree. Whatever this angle, 60 degree. Because it is 30 plus 60. This angle is making 90 degree. Now it is 60 degree. Now total angle between T2 and the weight E is 150. It is 90. E weight 1000 newtons. And whatever the angle between T1 and E, that is 120 degrees. T2, angle between T2 and E is 150 degree. Now if you apply the Lamis theorem, we can know what is the Lamis theorem. How to start? From that free body diagram, T1 by sine of the angle between other two, sine of 150. Now T2 by sine of the angle between other two, T1 and E, that is sine of 120 degree. Now next, E by sine of the angle between other two forces, that is T1 and T2, that is sine 90 degree. What is the E value here? We know the value of the E, T1 sine of 150 degree equal to T2 sine of 120 degree. What is the value of the E? That is 1000 newtons, 1000 sine of 90 degrees. Now, if we equate T1 by sine 150 degree equal to 1000 by sine 90 degrees, from that T1 comes. If we equate T2 with sine of 120, T2 by sine 120 equal to 1000 by sine 90, then from that T2 will be obtained. Thus, we have to solve the tensions in the chains, chain 1 number 1 and chain number 2. This is the way of doing it. All right. And let us see in our solution. The T1, this is as I mentioned here, it is 30 plus 90, 120, it is 150. The T1 and the T2 and E equal to 1000. Yeah, T1 by sine 150 equal to T2 by sine 120 and 1000 by sine 90. So if you consider this is the portion 1, and if we consider T2 is the part 2, this is the part 2 and it is part 1, and finally final part is, and here it is the part 3. Equate part 1 equal to part 3, then T1 comes. Equate part 2 equal to part 3, then T2 will be obtained. Now, T1 by sine 150 equal to T2 by sine 120 equal to 1000. T1 equal to 1000 times sine 150, that is 500 newtons. T1 is obtained as 500 newtons. What about T2? T2 equal to 1000 times sine 120, that is 0.866, that is 866 newtons. T1 is obtained as 500 newtons. T2 is obtained as 866 newtons. Alright, T1 and T2. Thus, we have derived the values, or we have calculated the tensions in the chain 1 is 500 newtons and chain 2 is 866 newtons. Why we got T1 is greater than T2? Why we got T1 value is 500 newtons? Yeah, T1 is less than T2. T2 is obtained as 866 newtons. T1 equal 500 newtons. T2 is 866. Why T2 is greater than T1, or why T1 is less than T2? So here, why T1? Here the T1, yes, why T1? Here the T1 is making here 1000 newtons. The 1000 newtons force is making here the T1, the angle with which is making, that is 120 degrees. So the value of, very important, T1 is proportional to the sine of the angle between the other two. That means 500 newtons T1 is proportional to sine 150. Whereas T2 is proportional to the sine of the angle T2 by sine 120. Okay. So the value of sine of 150, sine of 150 means sine 90 plus 60, that is sine 90 plus 60 cos 60 1 by 2. The value of the sine of the angle here very important. T1 is proportional to the sine of the angle between other two, that is sine 150. T2 is proportional to the sine of the angle between other two, sine 120. The value of the sine 150, the value, what is the sine 150 degree equal to 0.5. Okay, that means T1 is proportional to 0.5 value, whereas T2 is proportional to how much? Sine of 120, that is 0.866. So the value of 0.866 for T2 is greater than the value of the point T1 proportionality, that is 0.5. So the value of the T1 is proportionality value is 0.25, 0.5. T2 proportionality is 0.866. 0.866 T2 value is greater proportionality. That's why T2 value become greater, more value in comparison to T1 value. Okay. The T1 value is smaller. Why? The proportionality is a small value in comparison to T2. The T2 value is more, proportionality value is more than the T1 value proportionality. That's why the value of T2 is greater than the value of T1. Is very important interpretation. Why we got T1 values smaller in comparison to T2 value. The concept came from the Lamis Theorem. So if you read the textbook, we can't get these interpretations unless and until the person who is having experience and he interprets and he speaks and he correlates between the concepts and the results, output results, calculated values. So this is the inherent mechanism, inherent concept between the Lamis theorem and the results obtained, the values of T1 and T2. Why the T1 value is the smaller than T2? If you put that question, if you question yourself with that question, then you have to come from the concept of Lamis theorem. By using the concept Lamis theorem, we can understand the reason behind why T1 value is smaller than T2. Okay. The next problem, we are going to take next problem so that we can understand better. A weight of 900 newtons is supported by two chains of lengths. AC is 4 meter and BC is 3 meters as shown in figure. Determine the tension in each chain. What are the tensions again? In previous model, the angles were given. How the T1 is making the angle with the horizontal AB, that is 30 degree. Alright. And here it is beta equal to 60 degree there. Now here, they not mention anything. They gave the geometry, the lengths of the chains T1 and T2 or AC or CB. Now how to find out these lengths? How to find out the tension in each one of them? So if you want to find out the tensions T1 and T2, we should know the angles between them. That is alpha or beta to be known and theta 1, theta 2 be known. Then only we can find out. If we know the alpha, the theta 1 can be calculated, that is 90 minus alpha. If we know the value of the beta, we can calculate the angle between, that is theta 2, that is 90 minus beta. How to find out? So if you draw that straight line, but the AB, the distance from A to B, AB is 5 meters. So whether this ABC is right angle triangle or not, if it is right angle triangle, we can make it the angle making the T1, T2 is 90 degree or not, we can see it. Now let us find out the Pythagoras theorem. AB square equal to AC square plus BC square. What is that AB square? That AB square equal to 5 square, that is 25. And AC square plus BC square, that is 4 square plus 3 square, that is 25. So AB square, AB is the hypotenuse or diagonal side. So the angle ACB, then it is making the C, A at C is the 90 degrees. The C is the 90 degree, it is A and B. AB is 5, AC is 4, BC is 3. So the angle B, here it is 90 degree. We got 90 degree. Yes, theta 1 plus theta 2, 90 degrees. Alright. Now, sine alpha. What is the sine alpha equal to? How to find out the sine alpha? Sine alpha equal to opposite side by diagonal. What is the opposite? That is BC by diagonal side AB. What is the BC here? The BC here it is 3 meters and AB here it is 5. 3 by 5. That is sine alpha equal to 0.6. What about alpha? That is sine inverse. That is 36 degrees 52 minutes. Now alpha plus beta equal to 90 degree because at point C is 90. Alpha plus beta equal to 90. Then alpha we know. What about beta? The beta value we got it 53.8 degrees. Now we know alpha and we know beta. Alright. Can we find out what is the theta 1 value? If it is theta 1, alpha value known, 90 minus theta 1 equal to 90 minus alpha. That is 53.8. Theta 2 equal to 90 minus beta. Substitute 90 minus beta, that is theta 2. Then theta 1 plus theta 2, you will get how much? 90 degrees. So the angle between, yes, what about BCE angles? Here it is alpha, then it becomes alpha. Then 90 plus alpha is the angle between. The 90 plus alpha, that is ACE. The angle between ACE equal to 126 degrees 52. That is 126 degrees 52. That is T1. Next T2. The T here it is 90 degree. T2 between here, the angle between BCE equal 900 newtons. How much it is? 143.8. 143 degrees 8 inches. 8 minutes. Now here T1 by sine 143.8 degree equal to T2 by sine 126.52 equal to 900 by sine 90. Sine 90 equal to 1. Now equate portion 1 and part 2 and it is part 3. Equate part 1 and part 3, we will get T1. And if we equate part 2 and part 3, then T1 first one, next T2. The T1 value is 537.44. 537.44 newtons is obtained. The value of the T2 is 720 newtons. So these are the values obtained. Again, this is the model number 2. The T1 and the T2, the tensions T1 and the T2 equal to what? T1 is 537.44 newtons. T2 is 720 newtons. So this is model number 2. What is the speciality of model number 2? The speciality of model number 2 is here the dimensions, the lengths of the chain 1, chain 2, and between them the lengths are given 5 meters, 4 meters and 3 meters. And we have to find out by using the concepts of geometry, find out the angles between them. And after that we applied Lamis Theorem. Thus we calculated the tensions of T1 and T2. And before model number 2, yes, this is the model number 2. In model 1, what is the speciality of the model 1? In model 1, we got the angles between the 30 degrees, 60 degrees, and here it is 90 degree. We know the angles between them. We have to find out the tensions of the chain 1 and the chain 2. Provided we know again force 1000 newtons here. So in this manner, what we have to do, we calculated in model 1 angles are known. In model 2 angles are not known. The length of the chains are known and between the chain connecting points are known. So in this manner we can apply Lamis theorem at different locations based on the geometry. But the requirement for applying Lamis theorem is the angles between the two, between them are to be known. Between the T1, T2 and E are known here. And provided one force, known force should be. Otherwise, we can't calculate other two forces. Here in this problem 1 or model 1, T1 and T2 are to be calculated. And the known value is the force at E. And known angles are known. So we can calculate, we can find easily. We can find the unknown tensions T1 and T2. That's what here in those two models, that is model 1 or problem 1 and problem 2, we applied Lamis theorem and calculated the reaction, the tensions T1 and T2. Okay. So in this session, we have learned what is Lamis theorem and what is the importance of Lamis theorem and derived expression for Lamis theorem. And by using Lamis theorem, we solved two models, model 1 and model 2. In model 1, angles between them are known. Angles between the chain T1 and T2 and E are, by using the concepts we calculated, but angles are given and calculate T1 and T2 are calculated. In model number 2, only length of those chains are given and between them angles are found, angles between them are found, and tensions T1 and T2 are calculated by using Lamis theorem. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.